Hi, good morning, everyone. So let's start in another 1 minute. I have shared my screen and I should be audible as well. Please give me a thumbs up if you can see my screen and if you can hear me out loud and clear. And let's get started. This is the first week of your cohort. All of you can hear me out, right? Okay. So, right. So let's get started. This is the first week of the cohort. And all of you have joined in the training session from the calendar option, right? And if you click on the material icon, which is the second icon on the left hand side here, you will see that all of your material is present in the material section. Now you are coming for the advanced training, so I'm expecting that you have taken the associate level data engineering, or you may have taken the certification, or you may have taken the training, or you may have equivalent knowledge of the associate level data engineering, and this is the advanced session. So basically, today we are covering the first week content, right? The first week is about the ETL pipelines. And you know that in Databricks, we create the ETL pipelines using Spark declarative pipeline, SDP pipelines. So week one is about SDP pipelines, and different type of architectures will be covered. How to do multiplex ingestion, how to use that multiplex ingestion table as a streaming source. How do you do you can say, how do you create a type 1 table, type 2 table in a data warehouse? So all of those type of topics will be there in this week, along with the ETL pipelines. So your ETL pipelines are supposed to pick up the data from the databases, and they are supposed to put the data into a type 1 or a type 2 table. Those type of scenarios will be there in this particular week. Now, the next week will be about data privacy. So different techniques will be there by which data can be secured, can be kept in a secured manner. Week number 3 will be about optimization. So week 3 is one of the most interesting week where all the optimization techniques will be covered. So how do you do storage optimization? How do you do cluster optimization? How do you do code optimization? So three categories of optimization can be there: storage, cluster, and code. So all three will be covered in week 3. And then the week 4 is about CI/CD. How do you create a CI/CD pipeline? How do you take the project into production? So imagine you have three environments. There is a dev environment, there is a staging environment, and then there is a prod environment. So how the CI/CD pipeline will be created. So in a nutshell, in 4 weeks, we'll be covering ETL pipelines, data privacy, optimizations, and the CI/CD concepts. Now, my name is Shivam. I will be your instructor for the week 1. In your session, multiple instructors will be there. So you will be seeing, you can say every week instructors will be different, right? So I'll be the instructor for this first week. And you basically, you must be aware that there are multiple sessions that we do in the same, sorry. So you must be aware that we do multiple sessions in the same, you can say, week. So all of these sessions are identical. Whichever is suitable for you, whichever time zone is suitable for you, you can join one of the sessions in that particular week. Now I'll take you forward, right? So this is now the labs. All the material is available on the left hand side here, right? And you have videos here. There are different labs which needs to be done. Assignments are there, and those assignments needs to be submitted. There are two more sessions today. Yeah. So just to repeat it, these sessions in the same week are identical. So all of these trainings are identical. So same thing will be covered in the same week. So you don't have to join all of them. You can join the one which is suitable, which is falling at a suitable time as per your current time zone. So we repeat the same content multiple times. So people from different countries and different time zones can join the training. So all of these are identical session. You don't have to join all of them. They will cover the same content, right? So the new content will be covered next week, right, over there. So these are all identical. Now the labs has, so you can open the labs from the material section, right, from here. So if you click on the lab section, you will find this option called as access the lab. And once you click on this access the lab will open in a new page. So If I click on this, it basically opens like that, right? It takes around 3-4 minutes for the page to be open. So I have clicked on it some time back. So it is already open here, right? Like that. Now, so in 3-4 minutes, when the page opens up, then when you will be doing the tutorials, please do find that option and do click on this URL. So when you click on the Databricks URL, the lab environment, it opens in a full screen. So basically, we don't have to work in a window over here. It basically opens in full screen, something like that, right? So this is your this is how you will be accessing the lab environment by going to the lab section and click on access the lab, and then the lab opens in a different page. And just to open this in full screen, you can click on workspace URL, and the lab environment will open in full screen right over here. So this is where all of the demos are present, and this is where all the tutorials and everything will be present over here. Now we don't have a different slide deck. In Databricks, we are moving away from these slides. It was becoming more, you can say, slide-oriented training. So we are moving away from it. So slides are not there. What we have done, we have embedded the slides in the notebook itself. So if you go to the notebooks, you will see the slide notebooks are called as lecture now. So lecture is basically where images will be present. This is where you will. These are equivalent to a slide deck. So we don't have a separate slide deck. We have embedded the slide deck in the training itself, in the content itself, which is somewhere over here, right? Now, so just to take you a little bit forward, right? So this week, what we are talking about Spark declarative pipeline. Now, if you have just to quickly recap, in Databricks, if I click on the job section right over here, if I click on the job section, this is where you will see that there are multiple options. There is a Lakeflow job, Spark declarative pipeline, and then the Lakeflow Connect is somewhere over here. So somewhere here, if I click, this is called as Lakeflow Connect, right? So Lakeflow Connect is basically all the connectors by which the data can be ingested. Lakeflow job is all about orchestration, which is very similar to Apache Airflow, by which you can do an orchestration as such. You can run something sequentially, you can run something parallelly, and so on and so forth. This week topic is ETL pipeline. So this is what we are discussing over here, which is basically called as Spark declarative pipeline. Now, what do you do in Spark declarative pipeline? In very simple words, it's an ETL pipeline, right? So if you want to create, so if you have worked on any ETL tool before, if you have worked on, let's say, Data Factory, or maybe SSIS, or maybe if you have worked on Informatica's ETL tool, or any other ETL tool which is coming to your mind, Databricks ETL tool, it is called as Spark declarative pipeline. And the main logic is to create an ETL pipeline which can execute on a trigger. So that trigger can be when for example, there might be a landing zone here, right? So when the data will come, then the pipeline should run, or it should run on a schedule, or it can run manually also. So it is supposed to pick up the data from a source, will do all the transformation on the way, right? And will write the data in a target location. So the concept is around how to create ETL pipelines and how to create different architectures in that ETL pipeline. Now, I'll just get started from here. Now, so just to think about it, so imagine I have tables here, right? This is table 1, this is table 2, maybe I have a table 3, right? So we have a concept which is called as a flow, right? Flow. Now, flow, you can imagine something like over here. Imagine this is flow 1, this is flow 2. So flow basically will have a query. So there will be a query as part of a flow, and the flow will have a destination. So destination is the target location where the flow will write the data. So flow will pick up the data from somewhere, and the flow will be writing the data in some location after transformation. So how do you understand a flow? Flow is basically a query plus a target location, and the target location is where the data will be kept. So we can write different type of flows as such. Now, usually what we do incremental execution. So for example, imagine there is a landing zone, right? This landing zone can be the data lake of your cloud, where the upstream pipeline is putting some data here. Imagine there is an ETL pipeline which is putting the data in a landing zone. Now you want to ingest the data from the landing zone into your into the lakehouse architecture. So imagine there is a table here, bronze table, maybe there is a silver table, and then maybe we have a gold table over there. Now, whenever we want to do any type of ingestion, or whenever we want to do any type of processing, incremental is very, you can say it's a very common thing, that whatever new data is present, only move the new data. So whatever old data is there, don't move the old data because it is already processed. So you read the new data, write into the table, and then whatever new data is present over here, you read that new data and then you process that and you write into the silver table, and so on and so forth. So incremental processing is a very common thing whenever we think about ETL processing. So flows can do incremental processing. Now flows can also be resetted. So what we can do, we may say that there is a very big change which has happened. Now because of the change, you want to load the entire data and maybe want to reprocess the entire data using a different logic. So you are saying that, Shivam, do not discard the checkpoint, load everything from the source, process everything over there, and write everything in the sync. So if we need to discard the checkpoint and process the entire data, that technically is possible. So we call them as incremental mode and full refresh mode. In incremental mode, whatever new data is there, that will be processed. There will be a checkpoint which is maintained internally. And in full refresh mode, the checkpoint will be discarded, and all the records which are available in the source, all the records will be read, and all the records will be processed and will be written in the target location. Now if you think about the checkpoint, right? So the checkpoint basically, so if I so the checkpoint is flow specific, right? So imagine I have a flow 1 over here, and then there is a flow 2 which is writing into a different table, right? So just to remind you, what is a flow? Flow is basically a query plus a target location. So imagine I have a query and a target location. Target location is table T1 and the target location is table T2 for the flow 2, and the flow 1, the target location is table T1. So the checkpoint will be specific to the flow. So this will have its own checkpoint, which is independent of the checkpoint, which is of the second flow over here. Now, the good thing is, if there is a failure, imagine the flow 1 has a failure. So flow 1 failure will not impact flow 2. And next time when you will fix the failure and when you will rerun the execution, then flow 2 doesn't have to run because only flow 1 had the failure over there. So checkpoints are flow oriented, and it gives us the capability of partially running that particular flow itself. Rather than running all the flow, we can partially run like a part of the pipeline which has failed and process only the records which needs to be processed. So checkpoint, it is internally maintained by the flow, and the checkpoints are flow accordingly. So if I have 3 flows, all the 3 flows will have their own 3 checkpoints. Now just to think about it, right, how do we create that? Now if you just to because you are coming for the advanced training, I'm having an assumption that you have worked on the SDP pipeline before. So you know that in SDP pipeline we have two type of, basically the main two type of tables which are there. It's a streaming table, right? And the second type of table that you can create, it is a materialized view. So a streaming table, it is used for incremental ingestion and incremental processing. So whenever we want to get the data from our landing zone, let's say from an external location inside Databricks, then at that bronze layer, you will have the streaming table. And then imagine on top of the streaming table, there is a silver table here where you want to keep all the good quality data. So all the new data which is coming to this table is getting processed. We are doing deduplication, we are fixing all the schemas and all that, and we have good quality data in the silver layer. So streaming table is very suitable for a bronze layer, it's very suitable for a silver layer as well. And materialized view can be used anywhere, but materialized views are very suitable for a gold layer. If you think about it, gold layer is where we need all the aggregations, and gold layer is where on top of which you will be having some reports or some dashboards will be there, or some business users will be reading some data from that gold layer. So we create streaming tables and we create the materialized views. So if I create a streaming table like this, right? So imagine if I create streaming table name. So this internally will also create a flow. I don't have to explicitly define the flow, but it will get created over there internally. I can also define it like this. I can say I can make an empty table. I can make a table, create table over here, and then separately I can create a flow. So create flow, name of the flow, and then the logic will be written inside the flow. So what has to be loaded in that particular table will be written separately in the flow definition. So flow can be defined like this. Flow can also be defined like that, right? It gives you more control to define it like this. And this is like the default implicit flow. When we create a table, a flow will automatically get created. Now all the flows are independent, right? So imagine if these are three sources from where we are picking and we are writing into the same table. So the checkpoint for each one of them will be different, right? So if there is a failure in one of them, it will not impact the other one. And next time when we rerun the pipeline, only that what has failed can be executed, and what has not previously failed, that doesn't have to run again. So that is something very useful about the flows. Now, the data quality expectations, right? So there are three, basically four things technically can happen, right? First, the data may not have any issue with it, right? So imagine I have bronze data here, and this is the silver. There is a silver table. So imagine there is a bronze table here, and let's say there is a silver table, right? So then, by the nature of the bronze data, the data will be as it is. So as it is data may have nesting inside that. You may have JSON type data inside a column, right? You may have what you call as maybe something is wrong with the schema. Column names are wrong. Maybe extra columns are there. Maybe some columns are missing over there. Duplication of data is going on. So you want to deduplicate. So imagine I create a flow which reads from here, right? And as part of the flow, there is a query, and then there is a table, and table is this T1 table over here. So there are three possibilities. First, or four possibilities are there. If there is nothing wrong, right? For example, I want to enforce data quality expectation of my company, but all the expectations are met, then we will simply write in the silver table. But apart from that, there can be three more conditions. For example, imagine you were expecting some you were expecting some data quality expectations to be met, but those expectations were not met, right? So first we can do a warning, meaning write the data in the target location, just give me a warning, tell me how many rows were not following the expectation. So maybe we wrote 1000 records, and maybe 40 records were not having some proper expectation, so we will get a warning as such, but the data will be written in the target table. Second thing what we can do is we can say drop, right? So don't write in this table, simply drop it. So we are writing, you can say 1000 minus 40 over there, right? 960 records are being written, and 40 records are being dropped, which are not following the expectation of the company. An expectation can be any expectation on a value. You may want a value between a range, you may want a value below a range, beyond a range. You may want the email column to have domain name over there. So the email column should have dot and should have com, like that. So whatever expectations are there can be technically defined, and if they are not followed, then drop those records from the target table. Third thing that we can do is we can fail the flow. We can say simply fail it. It will not get, there will be a failure there. The pipeline will fail, and the data engineer has to go and fix that pipeline. Now this can be put in the conditions where there is a primary key missing. Imagine your primary keys or foreign keys which are required for join operations. So you're saying that, Shivam, if without the primary key, nothing will work downstream, because all the consistency will break. All the row identifiers are required. Without them, it will technically not work. So we can also fail the flow. So if there is some very important value which is missing, you can put that logic to fail the entire flow as such. Now, so here we have some examples of the expectation. So now just to think about it, right? This is the name of the expectation here. Expectation is a SQL constraint. Just in simple words, if you're coming from SQL background, or from a warehouse background, the SQL constraint that we have in Databricks in SDP pipeline, we call them as expectations. So expectations are the SQL constraint. So that's the name of the constraint. Like, this is how we will be seeing it in the logs, in the logs as such. And this is the condition of the constraint, what we want to happen. So we want the quality column to be bigger than 0 or equal to 0, right? That there's an expectation on total amount, expectation on the order timestamp, on the customer email address, on the quality column over there. So if you can see, right? So on violation, drop the record. So the records which are not equal to or greater than 0, those records will be dropped, will not be written in the target table. So they will not go in the target table, right? Same thing is here, drop the records. This is how you say, you can say fail. And by default it's a warning. So if you don't define anything, right, so imagine if I miss all of this over here, by default it will be a warning. Otherwise you can define it something like that. Now we can literally understand how many records were dropped, why were they dropped. So how many records were processed, how many records, why they were failing, what's the historical trend, right, what's the percentage of the records which are being dropped. System tables are also available. We can see all of this information from the UI. We can also see the information from a system table. Now just want to think about liquid clustering for a second here, right? If you are working in Databricks, you have come across liquid clustering, right? So technically, if you imagine this is my table right over here. Now, whenever we write anything in the table, the data, it goes in a snappy.parquet file in the data lake. So that's the data lake, and here are the snappy.parquet files. Now, if you write small, for example, if you do delete operations, if you do update operations, or if your amount of data that you are writing, it is smaller in size. Imagine 1,000 records. Maybe I'm writing 500 records, right? Maybe I'm writing 10 records, and so on and so forth. Or if I do delete operations, or if I do some sort of update operations, technically what will happen is a lot of your in a way, if you think about it, data, so technically the data is going in the snappy.parquet files right over there. So these are the data files where your records physically are kept in the data lake. Now what liquid clustering will do, right? So imagine, so I have some files here, right? Imagine these are some files here, and in the table there is a particular column which is called as product ID. So there is a product ID column there. So and there are some product IDs 99, there are some product IDs 100, some product IDs are there 101, 102. So imagine there is a product ID 99 record written over here, there is another record written here, there is a record written there, right? Maybe one record of 100 is here, one record of 100 is there, and so on and so forth, right? Maybe data is, so in very simple words, data is scattered around. So when data was being written into the table physically inside the data lake, when the data was being written into snappy.parquet files, data was scattered around, it was written in multiple files. So the problem is whenever you will try to read from this table, right? Imagine if I run a query where the product ID, it is equal to 99. If I run a query like that, now this file will also be read, this file will also be read, this file will also be read. So multiple files are being read, more scan operation is happening, you are reading more from the data lake. It will take more time also to read more data, it will be more costly also to read more data, and your overall your query execution will be slower because you are reading more data. So now what liquid clustering will do, right? So imagine, now there are two ways in which we can do it, right? First, we can do it by specifying the column ourselves. So imagine you are saying region, comma, order date, or you can say that Databricks automatically select the key for the liquid clustering. So right, imagine, so there are two ways in which we can do it. And just to think about it, right, same scenario. So imagine if my column over here was product ID column, right? If I do it on product ID, then technically what will happen is whenever I will try to write in that table, right? So I'm writing in this table. Now the same data will go in same files. So all the records of 99 are coming here. Let's say these are all records of 99, like that, right? All the records of 100 are coming here, right? Maybe you have too much data of 99, so some more records are coming of 99 here, like that. There are some records of 102 which are over here. So what you will notice is that data got scattered. Rather than data getting scattered around, liquid clustering will ensure that your data, that the same file is kept in the uh, same row, or same, you can say record, it is kept in the same file. So data will be less scattered. It is not that scattered, it is less scattered, it is more co-located. So everything is which is similar is co-located based on the key that we are providing. So we can provide one key, we can provide more than one key also. So for example, you may have a scenario where you are saying that I want all the product ID to be, and I want liquid clustering to happen with the year column and with the product ID column. Then simply imagine all the 2016 data of the product ID 99 is there in this file over here, right? And maybe I have one more file where we have all the ID 99, but the year is 2017. So all 2017 data of the product ID 99 is there in this particular file over here. So your data can be co-located on a single column. Data can be co-located physically on multiple columns. So liquid clustering, now what technically will happen when we will run a query on this particular table, the query will be running way faster because the unnecessary data is getting skipped. These files will not be scanned, they will be skipped. Only the necessary data will be read. You are reading less amount of data. You need less RAM also in the cluster to load less amount of data. The read will be faster, your query will be executing overall faster. So liquid clustering has very good benefits when it comes to read performance. So now the main thing is we can do the liquid clustering, let's say, by defining the columns as such. If you want the keys to be automatically selected, then you can also set the liquid clustering to be auto, and then the columns will be automatically selected by the liquid clustering itself based on the you can say the type of queries which are coming. So if the more queries are coming on the order date will be part of the liquid clustering logic. If the more queries are coming on the region, then that particular region column will be selected. And if the pattern changes, the keys can be changed on the way. So now some other columns are being selected. Maybe after 6 months, if your pattern changes, then the you can say the columns will change over there. So all of this is in the first notebook. And just to take you a little bit forward, right, I just want to cover a little bit more content here. So once you go through the basics of liquid clustering, the next thing is how to make an ETL pipeline, right? How to make you can say ETL pipeline. How do you do multiplex ingestion as such? So the scenario is something like this, right? Yeah. So let me see if I can find the image. I guess the image is here. Just 1 second. Let me show you one image here. Okay, so I'll just draw it out for you. Okay, see. So now the logic is something like this, right? So imagine, right? Let's say we have a Kafka cluster. It can be Kafka, can be Event Hub, can be Kinesis, can be something else which is coming to your mind. So let's say there is a Kafka cluster here for now, and there are multiple streaming sources. So there is a maybe it's an IoT device that is streaming the data, right? There is a stream of data which is coming from an IoT device. Maybe there is a mobile application. So whenever the user is making some activity in the mobile application, we are capturing that activity, and it's a click stream which is coming from here. Maybe it's a database. Imagine there's a transactional database, and then there is a tool here, and that tool is capturing all the changes which are happening in the transactional database, and that all the changes are coming as a stream. So let's say there is a streaming scenario. So some data is coming as a stream, and we have a Kafka cluster. This is Apache Kafka, can be Event Hub, can be Kinesis, can be Zero Bus in Databricks, right? And in that Kafka, there are multiple topics over here. There is a topic 1, there is a topic 2, there is a topic 3, and some partitions are there, maybe 3 partitions, maybe 10 partitions, maybe 20 partitions are there. So imagine some partitions are there. So what I want to think about is that I have 3 different sources, right? And the data is going somewhere here. So the data from the IoT device, it's coming in this location. Data from the second mobile application, it's coming in this location. And then the data from the transactional database, it is coming in this location. Now what I can do is, so if you think about this, Databricks is somewhere here, right? So this is Databricks. Imagine behind Apache Kafka, the consumer behind Kafka, from where all the queries are running over there. So let's say this is where we have a table, right? And in this table, what we are doing, we are ingesting data from technically from that table point of view, this is one source, right? This is one source over there. We do have multiple event type data inside that, but that technically is one source. So what we can do, we can simply ingest the data from different topics into one single table. This table is called as a multiplex ingestion table. And then we can put like a parser. So imagine you have multiple tables behind it. Maybe it is having 10 columns. Maybe this table is having 3 columns, right? Maybe this table is having 20 columns and all that, right? So there are multiple tables over here. So then we read from here, right? We parse it. We say, okay, IoT data goes into this IoT table, right? The clickstream data goes into this clickstream table. and the OLTP data, it goes into this table, right? So we put a parser, we basically uh, filter the records based on the type of event that we are getting, and we put them into multiple table. So this is your scenario. You have to create a multiplex ingestion table, right? So it's a Kafka scenario. We don't have a real Kafka cluster, but we have the real schema of a Kafka cluster, meaning the way the Kafka provide you data, same way we are going to provide data in a JSON file, right? So our data will be in a JSON file, and we will try to simulate like a Kafka oriented scenario. So we will be making, you have in this week, you have to make a multiplex ingestion table where the data is being ingested, and then you will put filters on it. So filter 1, filter 2, filter 3, and then you will use that particular table as a source table to stream data into further tables down the pipeline. So you will filter and you will put data into multiple tables, and then you will do more processing on top of it. So this will be your scenario, one of the scenario in this week, to make a multiplex ingestion pattern, and then to use that multiplex ingestion table and then do a fan out on top of it. So use that table as a source and then write into multiple tables down the pipeline, right over there. Now, in the same line of thought, there is a very common scenario which is called as a change data capture scenario, CDC scenario. So in a CDC scenario, and CDC is a very, very common thing, right? So uh, just to think about it, imagine this is Oracle here, right? Oracle, MySQL, Postgres, or any other transactional database which is coming to your mind, right? So imagine that's the database here, right? So every good transactional database, they have what we call as a CDC concept as part of it. In uh, in Oracle, it is called as Golden Gate. In Postgres also there is a CDC concept, right? In MySQL also they have a CDC concept. And just uh, right, and just to show you few things, imagine you use a database which doesn't have a CDC, you can say, capturing mechanism. What we can do, we can also use open source tools like Debezium. I'll drop this link in the chat window. So so you have to install this on your transactional database. So it supports MongoDB, MariaDB, Postgres, right? Cassandra, Spanner, and so on and so forth, right? These are the databases which it supports. Now, what are we discussing about here is that imagine we have a transactional database. Now, either the CDC tool will be inbuilt over there, or we have to install the third party CDC tool like Debezium, but we need a CDC tool. Now, what this CDC tool is doing, it is keeping a track of all the changes which are happening. So when any customer, they add a new address, let's say in an e-commerce scenario, they are adding a new address. There is an address which they are adding or updating, or something, they are deleting some address, right? So if you think about the changes which can happen in a transactional database, there can be three type of changes, right? We can insert something over there. There might be a delete change, right? Or there might be an update change. There some value might be updated, some value might be deleted, some value might be inserted. So whatever changes are happening, the CDC tool, they capture those changes. Now these CDC tool, there are two line of thoughts after that. You can have like a cold path, you can have like a hot path. In a cold path, basically there is a streaming scenario. So the CDC tool, it streams the changes. Whatever changes are happening, they're streamed. And then somewhere here will be Apache Kafka, right? So Apache Kafka or Event Hub or Zero Bus. So this is Kafka, and Databricks will be somewhere behind that. So a very low latency solution, which is very, very fast, can be like a hot path. And in a cold path, the CDC tool, it writes into a volume in a data lake. So imagine there is a data lake here, and then there is a volume inside the data lake, and all the changes are being written over here. Now, in the training that we are doing, we don't have a real Kafka. But we are trying to simulate that streaming scenario by using a cold path, which is a data lake, right over there. So in a data lake, data will be present. And then what we have to do is we basically have to create the ETL pipeline. So the changes which are happening in the transactional database, those changes will be coming to Databricks, right? Now, this is where there are two type of tables which we will be creating. It's called as a type 1 or type 2 table. Slowly changing dimension type 1 table, slowly changing dimension type 2 table. So imagine SCD type 1 table, and there is a slowly changing dimension type 2 table. Now, A type 1 table in warehousing, it's an exact replica of the transactional table. So whatever this table is, T1 table, this table will be an exact replica of it. So if any insert happen here, any delete happen there, or any update happen there, we are going to overwrite the changes, and this table will be an identical table to the transactional table. So all the analytical team, right, they don't have to read from the transactional database. They can read all the data from the warehouse, and they can do analytics on top of it. They can do machine learning on it. They can do pattern recognition. They can make a classification solution. They can make recommendation solution on top of it. So they don't have to read from a transactional database. They can read the analytical copy of the data, which is an identical copy. So type 1 table is basically an identical copy of your transactional database table. And a type 2 table is a table where we are also maintaining the history of the change. So imagine the customer was living in some city from 2016 till 2017, right? And then the customer changed the address. So from 2017 till 2026, they are living in a different location as such. So we also maintain the history. So we will have the current values, that what is the current value of that value, or you can say the current record which is active in the transactional database, and what was the history of the change, what was the original, what was the old location where the customer was living, what was their preferences last year, what was the preference before it. So you will have the entire history of the change also in a type 2 table. So in this particular week, you are going to make a type 1 table and a type 2 table, which will be so we don't have a real transactional database, neither do we have a real Kafka, but we are starting from somewhere here, right? So we'll have a location where all the changes will be present, which is coming from a transactional database. And then we are going to make a type 1 and a type 2 table. And using those tables, you can say a lot of analytics can happen on that table. A type 1 table is an exact replica, and a type 2 table is a will also have the history apart from the current value in the transactional database. So this is the scenario here, which is called as a change data capture scenario, where the changes which are coming from the transactional databases, they will be you can say they have to be captured in the warehouse into a SCD type 1 and a type 2 table, right, over there. Now I just want to show you this scenario itself, right? So now how are you going to do that, right? The cluster is serverless cluster, right? And so yeah, we are making a type 2 table in this particular demo. So I'll show you the demo. I'll walk you through the syntax, the code of it, and any other detail which comes on the way. I'll show you all those details also on the way. Now, just to get started, right? So this is that location, the cold location, where the CDC tool is dumping the data coming from a transactional database. We have JSON files over there, and the data which we will be so we are ingesting the data as it is, right? So imagine there is a bronze table over here. Now because it's a bronze layer table, uh, where we are ingesting the JSON data, this will be having nested data inside that. So imagine there is a column where all the nested data is present. So we will read that data, we will parse it, we will remove the nesting, right, flatten it out. So in the silver layer, you will, so in the clean bronze table, you will have flattened data. So that data which was nested earlier will be flattened later on. Then the logic will start. So now we will have a type 2 table here, and this type 2 table, it's going to have the exact information of the data which is coming from transactional database, and it will also have the historical values there. What were the previous changes which happened in the transactional database? All of those changes will be there in that particular table. Then what we will do, we'll create two aggregates on top of it. First will be called as like a customer gold, you can say materialized view, and the other one is the current customers and the deleted customers. So which customers are active right now in the business, and what were the old customers who are no longer part of the company and some churn has happened. So imagine different type of CSM team or some other team will be reading from here and will be trying to understand how many customers have churned, why did they churn, did the renewal did not happen, or what was the problem, why the churn happened, right? So they can do those type of analysis. So we have to basically create the type 2 table and two multiplied view on top of it, which can be consumed by the downstream consumers. So, right, this is one of your assignments in this week. So I'll just walk you through this assignment here. And the cluster will be serverless cluster. There is nothing to change, right? And the upstream location is this. So, right, so that location is what I'm printing right now. And the classroom setup will do all the setup, will initialize the variables, and will is needed before we can get started. And right, so I'm just waiting for the classroom setup to complete. Okay, so now this is the volume, right? So that volume is basically somewhere here. I'll try to refresh. Yeah, so this is the schema, the bronze schema, and we have a volume there whose name is basically customer source file. So that's the volume, this one, right? This one. So this is the upstream location where the this is the landing zone where the data is coming from the CDC tool, right? So this is where it is landing, right? And we want to read the data from here, and we want to put that into a type 2 table, right? That's what we are trying to do. So we'll try to see how many files are there. I can literally see there is one file. We will just list it out that there is one file over there, right? So this is the file. Uh, Now, let's have a look at the data, right? What data do we have in that particular JSON file? So we are reading this. So we are saying read file function. Can you go to the volume? Can you read the JSON file whose name is 00 dot JSON, right? Format is JSON over there. And so this is the data that is coming from the transactional database. We have the address of the customer, city, the ID, email ID, name. Now operation is the important thing. So new, it represent insert operation. So this was the new record which was inserted in the transactional database. uh, Delete will be a record which is deleted, right, over there. And update will be a record which is updated. So operation type, this value, it is coming from the transactional database. So which record was inserted, which record was deleted, which record was updated. So new represent all the inserts which have happened. So these are all the records which are new customer records which came in the transactional database. Now we want to capture that into a warehouse, and we want to put them into a type 2 table so analytics can happen on top of it. So we have the timestamp, zip code, state, and then because we are using the read file function, that read file function is also giving a rescue data column by which any data which is not which is, you can say, missing columns, or let's say if the column names are missing or column names are, you can say, some data types are wrong, then all the wrong data types will get captured here. It will not go inside my table, it will get captured in the rescue data column. So it's a good functionality provided by the read file function. Now, what we are doing is, right, so now I will make the ETL pipeline. I'll just move this to my secondary screen, and let me take you to the ETL pipeline, right? So in the job page, in the ETL section here, the first ETL pipeline is getting created. And right, so the name of the ETL pipeline, so something like that, you will, in your assignments, you will change the name of the ETL pipeline. Now the schema can be changed from here, right, from the settings icon. So from here I can change uh, the basically the schema, and so on and so forth. So what I'm doing is I'm coming to this catalog. Catalog is correct, but the schema is not correct, right? This should be the other bronze one which was visible. And I'll just wait for it to be visible here, right? So we want to select the one. So the tables will get created in the schema which I'm selecting right now. I would like to select the bronze one. I'll wait for it to load. It seems to be still doing something. Okay, in the meantime, it is loading. I'll make other changes. So there are some other cosmetic change. We are changing the folder, like you will rename this and all that. So let's make those changes. In the meantime, it's loading. So imagine the folder is called as my pipeline folder, and right over here. So my pipeline, and I'll just refresh the page once, right? Give me a second. Let it refresh once, and then we'll make the changes. So some cosmetic changes are there. We want to change the name of the folder, name of the file. It's a Python file, PySpark file. We want to change this to SQL file. You can make a new file, or you can simply uh, rename the existing file. So I'm thinking of just renaming it. Otherwise, you can delete it from here, and then we can make a new file as well. So yeah, okay. So it's catching up, and let me open that one more time. Just give me a second. Let me open that again. Right. So, okay. So this is the pipeline here. Okay, great. So I'll just open the same pipeline again, and we'll make the changes. In the meantime, this is loading, right? I will walk you through the code. Don't want to keep you waiting there. So let me walk you through the code part of it. And right. So okay. So now check this out. See. So the very first thing we are going to do is, right. This is the logic of the first table. So there is a table that we want to create whose name will be customer bronze raw demo, and so that's the first table, right? And we are reading from the and this is where we are triggering the auto loader, right? This is the auto loader here. So we are saying auto loader, can you go to the volume where we have the data in the JSON format? Can you read all the data from there? So we are reading all the columns, and apart from all the columns, there are two extra columns that we are adding. One is processing time, and the other one is the source file, right? So basically, apart from all the columns, we are reading two more columns from the uh, we are making two new columns. So two new metadata columns are getting created. So this table is called as customer bronze. That's the first table where we are ingesting the data from the data lake, right over there, from the JSON file which is in the data lake, and this is where we are passing the path of it. So this will be the first table which I want to add over here. Yeah, okay. So let me add that now. So uh, let me start making the changes, and then so we can write the whole syntax in PySpark, or you can write the whole syntax in Spark SQL. We are using Spark SQL today. So let's make a SQL file. And in the SQL file, I'll put the first table there, right? So the first table is going here, right? Like this. Now, if you notice, it requires this particular variable, right? Now, this variable is the location of that volume from where the ingestion has to happen. So that I'm going to add, right? I'll just go to my schema here, and I will make the changes now. So let's select, yeah, okay. So the bronze schema, and I want to just reselect the the new folder. I think the folder name got changed. So my pipeline is a new folder name. So this will get fixed now because we changed that name. And the next thing I want to do is I want to add some variables here. So in the configuration section, I want to put uh, the the keyword source here, and the value it is coming from the volume, which I'm just copying from my secondary screen. I have the volume there, and that path I'm giving in this section. So that is going to inject in line number 15, right over there. Basically, that's the volume from where the data will be read. Now this is the first table that is getting created. Now on top of this first table, right, we are making another table where we are going to have, I'll just drop it for you, right? Now, so if you notice, this is the first table getting created here, where we are storing the data as it is. There is no change. We are just adding two more columns in line number 12 and line number 13 over here. Apart from everything which is there in the JSON file, we are loading everything. Now what we are doing, we are making another table on top of it, where we are putting some constraint. So first constraint is that the customer ID cannot be null. Customer ID is the most important column which we need for the row identification. So we are saying that customer ID cannot be null. If it is null, then simply fail the whole pipeline over there. Apart from that, we are not putting that failure record, failure clause. We are putting the drop clause. So if the operation column is null, then drop the record. The exception is that the name cannot be null. If it is a delete operation, then name can be null. Apart from that, name cannot be null. We don't want the name to be null. And there is another clause which is more like a, you can say, like a complex clause, which is having multiple and conditions here and or conditions here. So the address is not null, city is not null, state is not null, zip is not null. They can be null if the operation was delete operation in the transactional database, right? Then they could have been null as such. So another constraint is put here. And then there is a constraint on the email column, that the email column is supposed to have dot, right? It is supposed to have dot and com like that. So this is basically .com. That's your domain name, this much. And this is at the rate in the email column, and then the value before the at the rate. So it's like a properly structured email ID. Now, so these are all the constraints which are applied, right? So basically, 5 constraints are there. And we are reading from the previous table. All the 5 constraints will get applied, and then a data type conversion is happening over here. We are converting the Unix epoch timestamp into a more readable date timestamp over there. So this is happening in the second table. And now I will take you slightly forward, right? Now we are making a type 2 table. So first, it's an empty table. So we are saying that, okay, let's create a streaming table. Name of the table is customer silver SDD, slowly changing dimension to underscore demo. So now it's an empty table, right? It's like a normal empty table. Nothing is there. So this table will get created first, and then we are going to create a flow. That flow will be doing the rest of the heavy lifting over there. So this is the flow here, right? That's the main part of the entire tutorial. So we are making a flow, name of the flow. Now it is going to read, so that the target table is the table that we have created here. That's the empty table, and it is going to read from the previous bronze table, where the data was properly, you can say, where we have enforced 5 clauses. So this is the data where the data is present, which is on which we have enforced 5 constraint. Now there is a row identifier, right? Look at this particular key column, customer ID. Now customer ID is a row identifier, meaning, so the scenario is something like this, right? There is a transactional database where there is a customer number, let's say 123, right? So the customer 123 data is what we have ingested into the bronze table, and that's the data that we are eventually going to write into the type 2 table over there. So how do I know which record has to be modified, or which record has to be updated, or which records history are we capturing? That row identification will happen with an ID column. So that ID column that we are defining is the customer ID. So that's the same column here, that's the same column there, that's the same column here. So imagine there is an ID column uh, which we are through which the row identification will happen. Like, that's the record which has to be updated, or that's the record which has to be deleted. So how do you find that? You find that with the row identifier. So that's the row identifier. So it can be one column, can be more than one column, but they have to be unique columns. So they should uniquely identify the row itself. Now, apart from that, there is an important, in line number 89, you will see there is a sequence by. So for example, imagine the customer was, imagine the value was 3, right? The value became 5, and then the value became 4. So how do you know which came first, right? So this was the first operation, then the value became that, then the value became this. So there should be one column by which the sequencing can be understood. So which came first, right? This came first, or that came first, or that came first, or which came after what change. So a very useful column by which you can do sequencing is a time column. So any column which is having like a timestamp. So when was the customer living in city A? So city A, they were living in that particular year, or which we can get from a timestamp. When were the customer living in the other location? When was the customer living in the third location? So we can identify all of these type of important values from a sequence by column. So that's the sequence by column here, which is actually the timestamp column. And apart from that, we are saying that whenever that if any delete is there, uh, we don't disregard the delete, we want the delete, because it's a type 2 table. So what will happen if the customer is no longer with us, right? Imagine they have deleted their account in the transactional database. So that delete operation which is coming from there, that delete operation, what we want to do, we want to insert the end date. So imagine there is a start date, there is an end date. So customer was living from 2016 till 2026, they were with us, right? So what we want, that end date to be captured. So we are saying, okay, so start date is 2016, end date is, let's say, 2026. So this is the end date. Now they are no longer with us. So we want, even if the customer is gone, we if we can maintain the history or the some previous records in terms of the old addresses where they were living, what were their old preferences, what was the old values as such, which will give us better analytical results. So we are saying, don't we want the delete operations to be applicable as well, and make a type 2 table. So we just have to define a type 2 table over here. Now, if I run it, right? So that's all. So we'll just run it. That's your assignment. You will run it after that, and then it will take few seconds for it to execute, right? So right, so if you click on the pipeline graph, that graph is getting created here. If I click on this option, it will come in a full screen, right? So if I click here, it basically comes in full screen like that. So I'll just keep it open in full screen. So the tables are getting created, right? Okay, so this is the first table. uh, the volume is not visible, but volume is somewhere imagined somewhere here, right? So that's the volume where the data was landing from the transactional database, right? And then there's the first table where we are loading that data. So the first table is having the address, city, and all the information here, right? Like this. And then the second table is the one where we have enforced 5 constraint. So this data is the source of truth, or this is the data that we have maintained after uh, what we call as after implementing the data quality constraint as such. So somewhere here, imagine somewhere here, the data quality rules were enforced, right, over there. Now, I should be able to show you more details as well. 5 expectations were set. If I click on them, right? If I click here on all, right? So it will show me which 5 constraints were there. So valid email ID, valid address, valid email ID, valid ID, name, and operation, right? And nothing has failed. Everything has passed. So all the records were there is no failure, right? Or whatever data we have here, all the data came in this particular table also, right? Now, this is the type 2 table, which I would like you to have a look at. So this is the type 2 table. That's the main table here. And in this, there are 2 extra columns which are there, right? This is the start date. This is the end date, right, over there. So if sorry, if there is a null in the end date, this means that this is the current record in the transactional database. So the current address or the current record of the customer is this particular record of the customer, whose ID will be, you can say, whose name is Cynthia, and the ID is somewhere on the left hand side. So that's the ID over here, right? Like that. Now, on top of this particular table, 2 more materialized views will be created, and those 2 materialized views will be eventually will be something like this, right? So these are two more materialized views which we are going to create now. And if I can scroll a little bit down, right, this is one of them. So how many customers are current customers, and how many customers have left the company, how much churn has happened. So in this we can have the churns, and the previous one we'll have the current customer records, right? These will be the That will be the last step. So I'll just go through, I'll bring you back, right? We have already reached the end of the time for the day. But there are multiple assignments like that, everyone, right? The labs are scenario based. Please go through the lectures. Please have a look at the demos, and you will find the labs. Labs are the ones where fill in the blanks are present. You have to fill those blanks over there. So go through the labs, submit your assignments, and if you have questions, please put the questions in the chat window or put the questions in the Q&A section. I have two questions in the Q&A section. I'll just go through them. Is it mandatory to attend the call? Am I following the uh, so the sessions, Rajeshwar, the sessions are basically, you can say, not mandatory to cover, but it's like good to cover, good to be part of the session, right? There is a self-learning section as well. So whatever we are covering, everything is part of the recordings, right? So if you click somewhere, you will see that recordings are there like that. Not of the this is the default. The whole training is recorded and is also provided to you, right? And the session that we are doing right now, that recording will be visible somewhere here. So once the training finish, you will see the recording coming up here of the live session. So you definitely can go through the entire content through these recorded sessions also. Now, what if the database does not have the field to operate upon? That operation field is mandatory, because without that particular field, the rest of the logic doesn't is not applicable. So we need to understand that in the transactional database, which record was you can say updated, which record was deleted. That information is required. So just to take you a little one step back, right? This particular column is a mandatory column for this scenario to work, right? So now whichever CDC tool is being used, that CDC tool will provide that particular column. So like for example, if this is Oracle, then which record was captured, deleted, updated, that information is being provided by that CDC tool over there. Now, there's a question in the Q&A section. Can you iterate what happens if one of the constraint did not pass, and how to handle it next time? Okay. Now, see, there are three possibilities. First, failure can be there, right? So if it's a failure, then literally you will see the pipeline fail, right? Like some step will fail over there. So the data engineer has to go and investigate what was the issue. Why was the primary key missing? Maybe in the source table. Maybe it is missing here because it did not come from the volume. So then why it did not come from the volume? Maybe when we were parsing it, that parser was not properly parsing it. Maybe the key is there, but it drifted into a different column. So it went into a different column as such. Or if it is not there also, then why is it not coming from the eventual source, or from the source itself? So that investigation will be the step if something fail. Now if there is a warning as such, right? The warning means that data was written in the target location, but you are getting a warning, like more informational in nature. So, and you may have a pipeline which is created in a way which is robust against any warnings which are coming. So we are okay with the warning. Now the third thing is there is a drop record, right? Now in drop record, we have to handle that. So we have to make another table which you can call as a quarantine table. So let's say all the good quality data, it is going in your silver table, and all the bad quality data, it is going in the quarantine table. So the records which are dropped from here, imagine 40 records are dropped, those records have to be added into the quarantine table, otherwise they literally will be dropped. So we want to drop them, but only from the source of truth. That bad record we want to capture into a different table, and then we have to fix that either manually or automatically, and then we can write back into the same table later on. So that is not covered today, right? That quarantine table creation was not there, but it's like another table where all the bad records are going. So that was the answer for the question that was in the Q&A section. Okay, now in which scenario should we use a streaming table and a normal delta table? So inside the SDP pipeline, question from Bhavya, inside the SDP pipeline, right? The tables that we have here, the most common table inside the pipeline, that's a streaming table, right? Where we do incremental ingestion or where we do incremental, you can say, uh, processing. Now imagine, right, you have a table, but it's not part of the pipeline. You're saying that the table is not supposed to be maintained by this pipeline. So what I can do, I can make a sink, and that sink can be a normal delta table. So it is writing the data somewhere downstream, and some you can say we have consumers who are reading from that particular location. So like a normal delta table can be a sink also, or the normal delta table can be a source also, right? Imagine you are saying that this much we have inside the ETL pipeline, but I have a normal delta table. I want to read the data from the normal delta table and want to process that in a streaming fashion. So normal delta tables can be sources, normal delta tables can also be part of the sink. Inside the pipeline, normal delta tables will not be there. The tables will be streaming tables, or materialized views will be there inside the ETL pipeline. Okay, so that was the fourth question, which was there in the Q&A section. So okay, so I guess that's all the questions which were there. And okay, there's a new question. Anupama is asking, when is cloud file used? Okay, this is cloud files. See, uh, mm, let me show it to you. Right, see. Now, see, basically the concept is autoloader, right? So autoloader is the utility in Databricks by which you can load data from a data lake at a massive scale into a bronze table. Now, when we use SQL, the trigger word for autoloader, it is stream read file. So this is autoloader. Now, but if I use PySpark, right, then I will use the word cloud file. So cloud file is the trigger word for autoloader in PySpark, and stream read file is the trigger word for autoloader in SQL. So if you write SQL, you will write like this. If you use PySpark, then you will use the word cloud file. That's the trigger word for autoloader. So the replacement, so if this whole tutorial was in PySpark, in cell number 14, in this line number 14, you would have used the word, uh, you can say, cloud files over there to trigger the autoloader. Okay, that was the answer for the last question. Right, okay, so we don't have any more open questions right now. So we'll stop the session at this point. If you have more questions, please put them in the Q&A section here. If you go to this discussion section here, if you have any questions beyond the training as well, you just come here, click on the question, and just you put your questions here, right? So all the questions, they get captured in the question section. So if it's an open question, somebody will answer your question in the from here. So please use that section to ask the questions beyond the live session. Okay, so thanks for joining in, and do complete your assignments, right? Enjoy the rest of your day. Okay. Thanks everyone. Bye bye.